In example 4, we are going to construct a 90% confidence interval estimate of the difference between the two population proportions. We need to find the margin of error, but before we can do that, we need to find the critical value, p hat 1, p hat 2, q hat 1, and q hat 2. So let's start with the critical value. 90% confidence means there's 90% of the data in the center, so there's 0.05 in each tail. Using table A2 or inverse norm, you should find the critical value to be 1.645. Remember, we only need the positive critical value when we're dealing with a confidence interval. Now, p hat 1 would be the number of successes for the first sample, which is 192, over the sample size, which is 436. Rounding to 4 decimal places is 0.4404. Now q hat 1 is 1 minus that number, or 0.5596. P hat 2 is equal to the number of successes in the second sample, which is 40, over the sample size for the second sample, which is 121. Rounding to 4 decimal places, we have 0.3306. Q hat 2 is 1 minus that number, which is 0.6694. Now we can find E. The formula for the margin of error is the critical value. We multiply by this big square root, p hat 1 times q hat 1 over n1, plus, and then for the second fraction we have p hat 2 times q hat 2 over n2. So let's substitute in the numbers. The critical value is 1.645. P hat 1 is 0.4404. Q hat 1 is 0.5596. The first sample size is 436. Plus P hat 2 is 0.3306. Q hat 2 is 0.6694. The second sample size is 121. So working that all out, you should end up with 0.0805. Just a reminder that the margin of error for proportions should always be rounded to 4 decimal places. So now we can work on the confidence interval. Well, almost. We need to find p hat 1 minus p hat 2 first. So p hat 1 was 0.4404. P hat 2 was 0.3306. And subtracting, we have 0.1098. So our formula for a confidence interval, p hat 1 minus p hat 2 minus the error is less than, in the center we have p1 minus p2. On the right side we have p hat 1 minus p hat 2 in parentheses and plus the error. So that's why we needed to find p hat 1 minus p hat 2. So we substitute that value in, 0.1098 minus the error, which is 0.0805, is less than p1 minus p2, is less than, and on the other side we substitute in the numbers again, 0.1098 plus the error, 0.0805. So do the adding, do the subtracting, and For proportions, we want to round to 3 significant digits at the very end. So on the left side, you should end up with 0.0293 is less than P1 minus P2. And on the right side, you should end up with 0.190. One more question. Is there a substantial gap between the employees and the bosses? Well, since 0 is not within the confidence interval, there appears to be a substantial gap between employees and bosses.